All right, so let's next take a look at what happens in the F block and after the F block. So the F block is also called the inner transition metals, or the lanthanides and actinides. So if you look at the periodic table, the first one in this F block is lanthanum. So this series, this row is the lanthanides. And then below are the actinides. So you can know any kind of way you want. So let's take a look at some kind of oddities of the periodic table. So let's take a look at how the P table looks. Now you can see right there, that's what it looks like. So let's draw a little diagram of it. So we've kind of got this periodic table here, and then we've got these kind of two columns down here. These two columns, or two rows, my bad, are the F block. And similar to the transition metals, they're going to be a lower N. So these are actually N minus 2. The other oddities of this F block is that it's actually not down here. All of this stuff actually goes right here. So this is what the periodic table looks like, but here's what it really is. This is what the periodic table actually is. So what you can see is I've inserted my F block down into here as shown in the diagram above. So again, over here you have S along with helium. Here's F. Here's D. And then over here is P. So that's what the periodic table actually looks like. Why don't we draw the periodic table like this? Well, because it's really wide, so it'd take up more than a piece of paper, and very few people actually use F block elements. The lanthanides are somewhat used. The actinides are all radioactive, so that they have limited uses. So you can see the same thing on this pt11.com. Again, I'm a huge fan of this place. So all you have to do is go over here on this right and click wide. So I'm going to zoom out and show you what happens when I click wide. You see it inserts all of them into there, and you see how it's kind of inconvenient to have to scroll back and forth. So you can use this wide function to look at it. And then if you actually look at the periodic table, if you just Google periodic table, no, I didn't want to go to ptable.com. I want to Google periodic table. And you go to images. You'll see some differences here. So you see, look where the kind of transition metals go. You'll see this periodic table puts lanthanum and actinium actually in that block, while our other one didn't. You see this one keeps that block empty, and you can have different scenarios. So if you actually pay close attention to the periodic tables, they can actually look a little bit different than one another. So the filling of electron configurations in the F block gets quite confusing. So we'll say it's complicated. That's just a fancy way of saying confusing. And so I won't directly ask you to ever answer a question of what's the electron configuration of an F block element. That's not a question that I will ask you to require. I will ask for the after part, so elements after the F block. So let's take a look at that. So I got my handy dandy periodic table. And then let's take a look at lead, right? So lead's right here. So we can say, oh, look, it's got the same electron configuration as xenon, the noble gas above it. And then after that, we're thinking, let's do this in yellow, 6s2. And then again, read from left to right, line by line, just like a book. Well, if we're going left here, you see it's actually down here first, right? So we got to use up all this F block first, and it's actually N minus 2. So 6s2 4f, 4f. Think about how many electrons are there, right? You have 7 f orbitals, 2 per orbital, that's 14, or you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, actually 15 now. So you got to be a little bit careful because some periodic tables will put an element here while other ones will put it kind of down here. Sometimes lanthanum and actinum are up here, sometimes they're not. So you just want to know 14 electrons in the f orbitals. Now that we're done with that, we can continue going right. We've got our d orbitals next. So n minus 1, so we're at 6, so this is 5d10. And again, the counting is going to be a little bit funky down here depending on which periodic table you're using. And then finally, then we go to lead. We're back at 6, 6p1, 6p2. So there's the electron configuration for lead, Pb. If you're thinking about how many valence electrons this has, that is a valid question and answerable. Remember, we're going for the highest n value. So our highest n is 6, and so lead has 4 valence electrons, and lead normally takes a charge of +2 or +4. So you can see it's kind of reflected there. We'll learn more about that later on. Remember, F block is n minus 2, D block is n minus 1. So know all of that. And how many things or how many electrons per set of orbitals? Remember your SP, D, F, and M sub L and L stuff. So we have SP, D, and F. So remember, when you have an s orbital, that means L equals 0. P orbital, L equals 1. D orbital, L equals 2. F orbital, L equals 3. And then remember, M sub L is what tells us how many orbitals there are. So M sub L from negative L to 0 to L. So when it's just 0, it's just 0. And then you count how many orbitals there are. There's 1 here, so it's 1 orbital, which then obviously would correspond to 2 electrons, because 2 electrons per orbital. M sub L here can be -1, 0, or 1. So that's 1, 2, 3 orbitals, or 6 electrons. L here is 2, so M sub L can be -2, -1, 0, 1, or 2. So if we count that, that's 1, 2, 3, 4, 5. That's 5 orbitals, or 10 electrons. Here, M sub L can be -3, -2, -1, 0, 1, 2, or 3. If you count that, that's 1, 2, 3, 4, 5, 6, 7. So that's 7 orbitals, or 14 electrons in there. So be comfortable. At this point, we've basically covered the electron configurations of all of our elements. The only thing I won't ask you for is F block elements, but I will ask you for stuff after the F block. So be prepared.